Hello everyone, welcome to Simply GIS YouTube channel. This channel is dedicated to exploring remote sensing, GIS and digital image processing, covering essential tools and techniques for geospatial mapping and analysis. Whether you are a student, researcher, teacher or professional, this channel will help you enhance your GIS skills and apply them to real world challenges. In this exercise, we will learn how to calculate land surface temperature using Landsat 8 collection 2 level 2 data. You will find many videos on YouTube showing the methods of calculating land surface temperature using Landsat data. This traditional method is complex and requires three bands, which are band 10, that is the thermal band, band 4 and band 5, which are used for calculating NDVI. In this method, we first convert the DN values of thermal band to top of atmospheric radiance. Then in step 2, we convert the top of atmospheric radiance to brightness temperature. At the same time, we calculate the normalized difference vegetation index using band 4 and band 5. Then the NDVI map is used to extract proportionate of vegetation, and with the help of the proportionate of vegetation, we calculate the land surface emissivity. Finally, using the brightness temperature and land surface emissivity, we can calculate the land surface temperature. This traditional method is applicable when you are calculating land surface temperature using Landsat level 1 data. For Landsat collection 2 level 2 data, you don't need to follow that complex methods. The band 10 in collection 2 level 2 data are pre-processed and they contain the surface temperature values in digital numbers. What we need to do is to convert the DN values to our desired unit of measurement, that might be degree Celsius, degree Fahrenheit or degree Kelvin. The formula for calculating land surface temperature using collection 2 level 2 surface temperature band 10 is very simple. We don't need any other bands like band 4 and band 5 for NDVI. We just need this band 10, and the equation is dn multiplied by multiplicative rescaling factor, which is also called gain factor, plus additive rescaling factor, which is also called additive offset value. You can find these ml and al values in Landsat metadata file, which comes with the data when you download it from the USGS Earth Explorer. So in this metadata file, you can see under group level 2 surface temperature parameters, temperature multiband ST surface temperature band 10 value is 0.00341802. This is the ml value, and temperature additive band ST band 10 value is 149. This is the AL value. So we got the ml and AL value. So using this formula, we can calculate the land surface temperature in a simple and easy way. This is the simplest way for calculating land surface temperature. So I'm going to ArcMap, and in ArcMap, I have already added the Landsat 8 level 2 surface temperature band 10. The path and row for this tile is 145 and 40, and the date of acquisition of this data is 12 November 2024, and my area of study is Bareilly. This is the Bareilly districts in Uttar Pradesh. So for calculating the land surface temperature, I will go to Arc Toolbox, and in Arc Toolbox, we'll go to Spatial Analysis tool, Map Algebra, then Raster Calculator. Before that, let me shorten the name of the Landsat layer because it might create confusion. So I'm going to the layer and double clicking it. So I am renaming it with short name. So again, I am going to Spatial Analyst tool, raster calculator. Now the name of the band is short, so it will help us easy calculation. There will be no confusion. Okay, so I'm going to DN value. This is the band 10 multiplied by ML value. This is I'm copying it, pasting the ML value plus AL value, that is 149. I'm again copying it. Control. So this is the formula, but if you execute with this formula, the output result will be in degree Kelvin. But we need to convert this degree Kelvin to degree Celsius. For that reason, I will subtract 273.15. So I'm doing it, minus 273.15. And in output raster, I will set the destination folder where I will save the output LST layer. So I'm going to my destination folder, teaching simplygising LST. Okay, I'm writing the name of the output layer, Bareilly LST dot pif. We need to define the raster dataset format as .pif, otherwise the execution will not be successful. Okay, I'm saving it. Then I want to confine the processing to my area of study and clip the output only for a study area, that is Bareilly. To do that, I will go to environment, change the processing extent to area of interest, and in the raster analysis I will mask the output with AOI. Clicking OK. So my map algebra expression is OK, and I have also set the destination folder where my output data will be saved. At the same time, I have also set the area of interest for clipping the output layer. Okay, now I am clicking on OK. So here is the output map. I'm unticking the first band. Okay, zoom to layer. This is the LST map for Bareilly, and the values are ranging from 24 to 37. I told you the Landsat data is of 12th of November 2024. Seems the value is correct. For better visualization of the map, I will go to properties, and in properties I will change the symbology to blue and red combination. So this is the easy and simple method of calculating land surface temperature using Landsat 8 collection 2 level 2 data. You don't need to go through the complex process using level 2 data. Thank you.